Good day to the audience. I'm Shen, and today I'll be presenting my final year project titled BioClassify. We're living in a time where technology and artificial intelligence are transforming nearly every industry, and healthcare is no exception. AI is now being used to predict diseases, analyze medical dataset, and even assist medical researchers in making accurate and more reliable diagnosis. But for AI to work, it needs quality data and a usable interface. But that's where many challenges begin. In fact, when I surveyed potential users, most didn't struggle with understanding AI itself, but the main barrier was the lack of access to analytical tools. And also, manual data pre-processing is too time-consuming for them. And when I asked what they wanted most in an AI tool, they said that they want pre-trained models, automated pre-processing, and also easy data upload features. So, in reality, applying AI in medical research isn't always smooth because of the complexity of medical datasets. It's often with missing values and inconsistent formatting. And there are a lot of AI tools out there that require coding skills, which medical professionals and researchers don't have. And even if tools are available, choosing the right machine learning model can be confusing without clear evaluation metrics. And that's why these problems limit how widely AI can be adopted in everyday medical research. So, this led to the development of BioClassify, a no-code, web-based platform that allows users to apply machine learning model on medical datasets without writing any code. It's designed for two groups of users. The first one is clinicians, who can run predictions and generate diagnostic reports. Second one is researchers, who can upload data, train different models, and analyze performance, all through a simple interface. So, first, no coding is needed for BioClassify. Users can just upload their data, choose a few settings, and run the system. Everything happens through buttons and menus. Second one is the custom model training. The system lets users to train and compare different machine learning models. It's like testing out 8 different doctors and seeing who gives the best advice. And the third one, which is accessible for non-technical users. It's designed for people without a tech background, whether you're a medical student, a clinician, or a researcher. You can explore AI tools without needing to be a programmer. And these are all supported by the backbone of BioClassify. BioClassify uses 8 different machine learning models, also called supervised classifiers. These models are trained to recognize patterns in data and make predictions. For example, whether a patient is high or low risk based on their medical information. Before we can use that data, it needs to be cleaned and prepared. And the system has an automated pre-processing pipeline that fixes that missing values, organizes columns, and gets everything ready for training, without the user to do it manually. Once models are trained, the system shows clear performance results like accuracy, precision, and recall. This helps users to compare which model works best for their dataset. And a perk for researchers who wants to explore further, there's a sandbox section. It lets users upload custom data, adjust their settings, and test multiple models in one place, perfect for experimentation. So, this is the overall module diagram for BioClassify. And this module diagram follows a standard ML machine learning pipeline. So, the first user, whether a clinician or a researcher, uploads a medical dataset using the platform. And next, the system runs automated pre-processing, which means it cleans the data, fills in missing values, and formats it so it's ready for machine learning. Then the user can choose from 8 machine learning models, and the system will train them in the background. And after training, the evaluation models show how each model performs using metrics like accuracy, precision, and recall. And finally, users can run predictions on their new data or model and generate a report for the model generated. All of this happens through a user-friendly interface without needing to write any code. And the system architecture, BioClassify is built with Next.js and Tailwind CSS for a much polished front end. The backend uses simple Python and fast API for the machine learning engine and the data pre-processing. And all of the models and datasets are stored in Supabase for security. So let us proceed to the demonstration. In this session, I'll walk you through how the platform works. The goal is to show how easy it is to use BioClassify. So let's go to sign in first. Inside the sign in section, users can either sign in with their account or sign up if users isn't registered yet. So here, user can either sign up as a user, a clinician, or a researcher if they want more advanced analytical tools and also custom model training. But in this case, I'll just use my researcher account to demonstrate this platform. So let's sign in. When user is signed in, it will redirect to the dashboard of BioClassify, where simple metrics like models, predictions, and recent activities are displayed. Users can also have access to data management, predictions, history, activity, and model training. Let's start by uploading a dataset. Users can just simply click on the Upload Dataset button, and users can upload their own dataset. In this case, I'll just upload a standard cervical cancer risk factors dataset. Okay, as you can see, that the dataset is uploaded, and also we can view the dataset too. In this case, BioClassify detects any missing values. And also give an overall analysis overview of the value distribution. Users can also check the data quality of their own datasets. After analyzing the overall analysis overview, users can clean their dataset. In this section, BioClassify detects any missing values of the columns and then give a strategy for them to fill in the missing values. In this case, I will just set everything as default and apply cleaning strategies. And once the cleaning is complete, users can either download it as a new CSV file or an Excel file. Now that the dataset is clean and pre-processed, now we can upload the clean dataset to train the model. Users can enter their own model name and also select the columns of target variables to train. Users can also select the features to also train the target variable. And then users can select the model to train. And also users can, by default, users are to select one from 8 models, but users can also choose multiple models to train. So in this case, I will choose 3 random models. Then here you go. Users can compare the models trained, and also the system will suggest the best model for the users to select based on the accuracy. So in this case, random forest and k nearest neighbors perform the best, so let's just save these 2 models. And then we can save. Then after the model training, users can use the models to predict on their own dataset too. After choosing and selecting the best model to save, users can now run their new predictions on the models that they trained. they simply upload new patient data and the system uses the trained model to generate. So here, users can either select from pre-trained models or their own custom models. So as you can see here, CC model 0 and CC model 0k nearest neighbors has been saved. So let's try it out. And users can also download a template to align their dataset to the previous model trained. Once the model template is saved, users can view the instructions inside the model template and follow it to fill in their dataset. So in this case, it will show the information of the model using train and the instructions to fill in the data. And this line shows the example of the values that needed to be input into the dataset. And these are the format that is needed for the predictions to be ran. And then users continue to upload their own dataset for predictions. So in this case, let's upload a test cervical cancer with no target variables. So after that, the prediction is run and users can save the analysis. After the predictions have been made, users can also go back to the history page where all the recent predictions and analyses will be here, and users can download back the previous prediction and the analyses. So in this case, let's just download. And users can save it to their local and also view it for further analysis. So this is an example of the predicted dataset. So when you scroll to the back, the predicted prediction will show here and with the probability class. While BioClassify already supports core features like data upload, model training, and predictions, there's still a lot more potential planning for the future. First of all, BioClassify will support team-based access, allowing researchers and clinicians to collaborate on the same project. Next, BioClassify will offer more ready-to-use datasets for various diseases like diabetes and heart disease, helping users to start faster without needing to clean or prepare any data. Thirdly, BioClassify will include explainable AI features, so users can understand why a prediction was made, increasing trust in clinical settings. So to wrap up, BioClassify is built with one goal in mind: to make machine learning simple, accessible, and practical. It lowers the barrier for medical professionals to use AI tools, even without programming skills. By automating the hard parts like data cleaning, model training, and evaluation, it allows users to focus on what truly matters, making better decisions and improving lives. So let's continue pushing forward, combining technology, compassion, and innovation. Together, we can shape a smarter, faster, and healthier future in healthcare. Thank you.